In this video, we're going to have a look at how to change the subject of the formula. This is a really important skill that comes up through all of maths, and allows us to manipulate equations to work out things that we don't know. I've got a particular strategy that I use here, and it's very closely aligned with solving equations, but I maybe do a step differently to how you might have seen it in the past. If we just think about a more basic equation such as this here, let's say that equals 19 for example. If we wanted to solve that, the goal is to isolate x. And if we think about what we have to do first, well, we need to take away 7 first from both sides, and then we divide both sides by 2. When we solve this, we actually think about what happens to x. So the first thing that happened to the x is that it was multiplied by 2, and then we added 7 to it. And how we solved that is we would kind of go in that direction, and we would do the opposite operation. So we would subtract 7, and then divide throughout by 2. And we would get x equals 6. It is this sort of framework here that I use to help rearrange the subject of the formula. Let's see how it works in practice. That methodology works in the majority of the situations. So change the subject of the formula to the letter in the brackets. So we've got d equals ex plus f, and we want to make e the subject of the formula. So I'm just going to highlight this here. So my goal is I want my final answer to be e equals. So what I'm going to do is I'm just going to bullet point at the side, and I'm going to say, what has happened to the subject? How does this expression been built? Well, the first thing I've done is I've multiplied e by x. Then after that, I added f to it. So if I want to make e the subject of the formula, I'm going to kind of work in this direction and work backwards. So the first thing I'm going to do is I'm going to subtract f from both sides. That's going to be d minus f equals ex. And then I want to undo multiplication by x, so I'm going to divide both sides by x. Divide both sides by x, so I'm going to get e equals d minus f over x. And that's us made e the subject of the formula. It is e equals. Okay, so if we can identify what is happening to the subject in the correct order that it happens, then we can work backwards and apply the opposite operation, or the inverse operation. Okay, here we've got the formula for the volume of a cone. V equals 1/3 pi r squared h. And we want to think about making r the subject of the formula. So my goal is I want it to be r equals. A few options here as to how you want to tackle this. So if we think about what has happened to r, hopefully you can see the first thing that has happened is that it has been squared. Yeah, because I would have to times it by itself to get r squared. Then after that, it has been multiplied by pi h. Yeah, I've multiplied it by pi h. And this here, I'll maybe rewrite it. That's the exact same as pi r squared h over 3. To find a third of something is the same as to divide by 3. I think it makes it a wee bit clearer in this case if we write divide by 3 as this step here. Okay, so how did I make this expression? Well, I took r, I squared it, I multiplied it by pi h, and then I divided it by 3. So if I want to make r the subject of the formula, I'm going to work backwards and do the opposite to both sides. So the first thing I'm going to do is multiply both sides by 3. I'm then going to do the opposite of multiplying by pi h. I'm going to divide by pi h. I'm going to get r squared is equal to 3v over pi h. Just change the order there so I had the subject on the left. Now my final operation I want to undo is squaring. The opposite of squaring, or the inverse of squaring, is to take the square root. So it's going to be 3v over pi h. Okay, so that's just one thing to look out for. When we had that third in front of it, it's often important to remember that we can write that as a division by 3. It makes the problem a bit more straightforward. So when the subject is just on one side of the equation, this strategy will always work. Let's have a look at this one. we want to make h the subject of the formula. The goal is we want it to be h equals. Let's think about what has happened to the subject. Well, the first thing that happened was it was square rooted. Then it was multiplied by 3. Then we added k. Then we divided by 2. So if I want to get h on its own, I'm going to need to work in the opposite direction and apply the inverse operation. So the inverse of division by 2 is to multiply both sides by 2. 3 root h plus k. Then I want to do the inverse of adding k, so I'm going to subtract k from both sides. I'm going to have 2g minus k is equal to 3 root h. I want to undo multiplicate times them by 3, so I'm going to divide throughout by 3. I'm just going to write this around the other way, so I'm going to have root h equals 2g minus k over 3. And then I want to do the opposite of the square root. Well, the opposite of the square root is squaring. So I'm going to square both sides. I'm going to have 2g minus k over 3 squared. If you write that, that is incorrect, because that just looks like you're squaring the k. You need to put the full expression in a bracket to show you you're squaring that full side. I want you to look at number 4 now, and hopefully notice the subtle difference with number 3 and number 4, in the sense that they look really similar. It's just that, like, the operations, the order has been slightly changed. I wanted to put this in just to see how these functions are built. So we want to make h the subject of the formula here. So what's the first thing that happened to it? Well, the first thing that happened is I times it by 3. And then I square rooted that. Then that I divided by 2. And then I added k. So do you see how it looks very similar, but the order, how it's been formed, is different. So we're going to need to do the inverse to both sides. So I'm going to need to undo this adding k. So I'm going to subtract k from both sides. That's going to be root 3h over 2. I want to do the inverse of dividing by 2. So I'm going to times both sides by 2. That's 2 lots of this side. I then want to do the inverse of the square root. So I'm going to need to square both sides. I'm going to need to square this side. This is starting to look a bit complicated. So I'm squaring this side, and that equals 3h. And then I want to work out h, so I need to divide throughout by 3. So h is going to be 2g minus k squared over 3. Now if I want to tidy that up a little bit, I could maybe say that's going to be 2 squared is 4. So that's 4g minus k squared over 3. So if you can understand examples 3 and examples 4, and you can work through those yourself, I think you'll be fine. So those examples there are where this strategy will always work. There are 2 cases where we need to think a little bit differently about it, where we need to employ a different strategy to work this out. So in this problem, we want to make x the subject of the formula. And the thing to notice here is that they've got x's on both sides of the equal sign. So I can't use my normal approach here. What we're going to have to do is we're going to need to get all the x's to one side and everything else to the other side. And then we'll go from there. So the first thing I would do is I want this 6x to be onto this side. So I'm going to subtract 6x from both sides. And I don't want this f here, this minus f. I'm going to add f to both sides. So that's going to give us ax minus 6x is equal to m plus f. So I've taken this to the left hand side and I've moved this to the right hand side. Remember, the goal is we want it to be x equals, so I want x on its own, and I can't get that here, not yet. So what we have to do in this case is we need to have a look at our left hand side and say, okay, ax minus 6x. Do you see how they both have x in common? What we can do here is we can take out a common factor of x. And if we do that, I would have a minus 6. And x is a common factor. But in this example, I'm just going to write that at the back. It's the same thing. That's m plus f. So if I want to make x the subject of the formula, it's being multiplied by a minus 6. So to get x on its own, I'll need to divide both sides by a minus 6. And that's going to give me x equals m plus f over a minus 6. Okay, so big thing here is if you have the subject on both sides of an equation, get them over to one side, and then you're probably going to need to be using a common factor. Last example, example 6. K squared is equal to 3s over p minus 1. We want to make p the subject of the formula. I want to work this out. So the thing that's tricky here that we need to think about is that yes, it's only on one side of the formula, but it's on a denominator of a fraction. That's really awkward. Because obviously I want my goal to be p equals, and the p is not part of a fraction. So what I'm going to need to do first here to start to resolve this is we're going to need to multiply both sides by p minus 1. I'll just move this over a little bit. I'm going to multiply this side by p minus 1. Because these would simplify, and then I would have k squared times p minus 1, and that equals 3s. So obviously the goal is to make p the subject of the formula. It's now not in the denominator, not as part of the denominator, which is good. So I can multiply out this bracket, k squared p minus k squared equals 3s. And now from here we can go ahead and make p the subject of the formula, because what's happened to it? It was multiplied by k squared, and then we subtracted k squared. So we're going to add k squared to both sides. So I've got k squared p is equal to 3s plus k squared. And then we'll divide both sides by k squared. That's going to be p equals 3s plus k squared over k squared. Okay, so I've taken us through like more or less all of National 5, changing the subject to the formula in this video. Quite a lot going on here, but it's really important skills if you want to progress further with your mathematics. Thank you very much.